Okay, so this video follows on from my previous video where I looked at average speed. So in this one, we're going to look at something called average acceleration. So I'm going to start off by defining what it is and actually describe the different kinds of acceleration that we can have. Then I'm going to look at how we actually calculate average acceleration, both from numbers and from a graph. And then I'm going to use a graph to compare different accelerations. So let's get started by defining average acceleration. So the average acceleration of an object is the change in speed divided by the time taken for that change to occur. And this is it in equation form. So the other form we might see this in is that the average acceleration is the gradient of a speed versus time graph. So that's what we've got on the right hand side. So the gradient is the change in y, so the change in speed divided by a change in x, so the time. So we can see that the average acceleration is the gradient of this graph. That's what average acceleration is. So let's look at different types of acceleration. So on the left, you can see a graph with a positive gradient because it's sloped upwards. So we would describe this as having positive acceleration because the speed is increasing. On the right hand side, you can see a graph with a negative gradient because it's sloping down. So we would say the acceleration of this object is negative because the speed is decreasing. And sometimes you might see that called deceleration. So those are the two different types. So let's actually do some calculations for average acceleration. So we can see, looking at this different speed versus time graph sections, that to start off with, we've got a certain acceleration, and in the second half, we've got a different acceleration there. So let's look at calculating those two accelerations. So the acceleration in the first section, the change in speed is 3 meters per second. The change in time is 1 second. So that gives us an acceleration of 3 meters per second squared. In the second section, the change in speed is half a meter per second. The time it takes is 2 seconds. So the acceleration during that phase is 0.25 meters per second squared. So those are the two different accelerations we can see on this graph. Okay, but what about if we want to calculate the average acceleration over the whole graph? Well, the total change in speed is 3.5. The total time taken is 3 seconds. So if we divide the change in speed by the time, we get the average acceleration over those 3 seconds, which is 1.2 meters per second squared. So what we say is the average acceleration over this period is 1.2 meters per second squared. Okay, so that's how we calculate average acceleration using numbers and the graph. So let's actually compare two different graphs and show what that means in terms of acceleration. So let's put this graph back up. So in the first section, we can see that it's steeper. So what that means is it has a bigger value of acceleration. In the second half, we can see the gradient is smaller because it's less steep. So we have a smaller value for acceleration during that section. And you can see that with the values that we calculated, it starts at 3 meters per second squared and ends at 0.25 meters per second squared. So we can see the acceleration gets smaller when the gradient gets smaller there. Okay, so let's have a look at the things that you should be able to do at this point. So you should be able to define what average acceleration is. So if you can't, go back and have a look. You should be able to describe the two types of acceleration, so positive and negative, which we also call deceleration. And you should also actually be able to calculate acceleration using both a graph and using numbers, and be able to compare different accelerations looking at a speed versus time graph. So if you can do all those things, that's great. If you have any questions, please feel free to comment on this video and ask, and I'll try and get back to you as quick as I can. But thank you very much for taking the time to watch this video.